Okay, the first short talk of the afternoon, Zoltán Balázs on sandboxing, sandbox detection, actually. You have the floor.
Hi, everyone. You have to know that this is a 45 minutes presentation compressed into 20 minutes. So fasten your seatbelts because we will travel with hyperspeed. This slide is dedicated about cyber to Cyber Peter, Cyber Kleisner, Cyber. And these are the things I have done. These are my researches, but we don't have time for this. This is the company I work for. And show me your hands. How many of you tried to analyze malware in a malware analysis sandbox, but it failed to run? Hands up. OK, great. How many of you guys tried to ever write malware and try to bypass the malware analysis sandboxes? OK, great. And how many of you tried to create a new malware analysis sandbox, like the guys from Checkpoint? OK. Or how many of you are into buying a new malware analysis sandbox to protect your company, for example? OK, great. So this presentation is for you. As you all know, the current malware analysis trends are that there is static analysis, there is dynamic analysis, and there is manual analysis. The static and dynamic ones can be automated. The manual cannot be automated. It is very easy to bypass the static and the dynamic analysis. It is very hard to bypass a good manual analyst, but if there are 400,000 new malware samples every day, then you can also bypass the manual analysts. So what are my problems with these malware analysis sandboxes? These were very great tools in the hands of malware analysts, and this was just one way of detecting new unknown malware on the network. But the problem is that nowadays these sandboxes are sold to companies, and they usually lack the resources, skills, or people to know how to interpret the reports from these magic sandboxes, which say that they will detect every new advanced persistent threats on your network. Nowadays, it is pretty common to do sandbox detection in almost every malware. But in the past, they have focused way too much on detecting virtualization systems. And it's kind of good, but I think it's nowadays a little bit outdated. Most of the techniques are flagged as malicious, or they are circumvented or simulated or whatever. So these are not the best ways to detect sandboxes anymore if you write a new malware. And in these screenshots on the left, you can see that I have created a new red sample. I have ticked all the anti-analysis checkboxes on this red sample. And I ran it on a system which was protected by a special defensive software. And this software tried to emulate the desktop machine as it is a virtualized environment. So first of all, the malware detected this as it's virtualized, so it quit. So it didn't infect the real user workstation. And on the other hand, the binary was flagged as malicious. So this is not the best way nowadays to do sandbox detection. So I have created a new malware, and I have uploaded it to the publicly available sandboxes and some of the private ones I had access to. And my malware can extract information from these malware analysis sandboxes. I implemented both known methods, and I have created new ideas to detect these sandboxes. And the easiest way to extract data from this malware analysis sandbox if I have direct HTTP connection to the internet, so I can leak every data to my server. There are some sandboxes which block direct connection to the internet, but they still try to resolve the domain names to IP addresses. So for example, if my malware tries to connect Microsoft Office is installed on this box.mydomain.com, and I operate the DNS server for mydomain.com, I can know for sure that on this sandbox, Microsoft Office was installed because I get the data through DNS tunneling. And last but not least, I can also use the report, whether it's publicly available or someone who operates this sandbox can send it to me, and I can hide these information in the report, like creating new files or something like that. But let me show you it in action, how it really looks like. So here what you can see that I upload my malware to this very good free online sandbox called Malware. It uses Cuckoo. And it's a really good service. I use it time to time. And here you can see that my server is waiting for the new connections. And for example, you can see that this malware analysis sandbox is using pretty old and small screen resolution. You can see what for example, it is running on VirtualBox. You can see that it is a Xeon-based processor, and so on and so on. So you can leak an awful lot of different information. Here you can see that the mouse event was emulated, so there were between different times the mouse position was different, and so on and so on. So you can get a lot of interesting data from these sandboxes. But when I checked the report for the results of my malware, I was able to see that where my malware was connecting by leaking all the data. And you can see soon that it was also flagged as malicious because I have already implemented old known techniques to detect sandboxes. And this Cuckoo sandbox was detecting it, that I tried to detect it. Okay, so in the next slides, I'm going to show you some of the tricks I have used in my malware. And whenever you see this big red thing, it means that this trick has a good sandbox detection effectiveness. It's not a very effective way to detect sandboxes. And when you see a trap and it's big, it means that this technique can be easily flagged as malicious, or it is already flagged as malicious in a lot of times. But if it's a small trap, then you as an attacker know that this is a good way to detect sandboxes because your malware won't be flagged as malicious. The first one was the screen resolution. And here you can see a statistics from a browser statistics company. And as you can see, it's around 7% of the users on the internet who are using 1024 square 768 screen resolution or lower. But let's see the sandboxes. 43% used this kind of resolution, and 36% used the 800 and 600 resolution, which is a big problem. But there was even one sandbox with 640, and I mean, they didn't even try to hide. This is a malware analysis sandbox. I have checked what kind of software is installed on this sandbox, which is usually not seen on usual user desktops. And the best one I have seen was this VMware tools. And the story behind this is that there are some malware which automatically checks for the presence of VMware tools. And the Sandbox developer thought that it is a great idea to rename the VMware tools to VMware tools. these are very common processes you can find on malware analysis sandboxes, but they are not very common on user desktops. One of my favorite techniques is the check for the processor type, because usually people don't care to fake it. And for example, if you are an exploit kit operator, you know for sure that you are targeting desktop users or notebooks or something like that. And if you see that the processor type is some 8-core processor, something specialized for servers like Xeon processors or Opteron ones, then you can be sure that this is not your target, but this is a sandbox. And I have seen some very old processors as well, like Intel Pentium 2 and Intel Pentium Pro. I have no idea what that was. But there were some sandboxes which used or at least faked real desktop processors like Intel Atom or Intel Core processors. It is again a well-known way to detect sandboxes, at least among penetration testers, to check for the number of cores of the processor. And it turned out that it works, but not every time. For example, I have seen one sandbox from Ukraine which used 4 cores, or at least it faked it. I have also checked for the computer system. And if you see, for example, box, then you can be sure that this is not a real user workstation. And in my research, I have found that almost 70% of these sandboxes were using some kind of virtualized environment. Almost 20 was some which looked like a desktop, but I'm sure they just faked it. And around 14 was something which looked like a server. I have also checked the mouse movement, whether it's simulated, that there is a user moving the mouse during the analysis. And it was pretty shocking to see that only 20% simulated the mouse movements. And there were some very basic positions on the screen where the mouse was used. So that was kind of shocking. I have also checked the memory size, because nowadays I'm not sure that a lot of people use computers with 1 GB of memory. You can even start YouTube with it. But still an awful lot of sandboxes used a low amount of memory, mostly because of the effectiveness. And if you have to run multiple sandboxes, multiple virtualized environments in parallel, then you have to keep short your memory assignments. But again, there were still some good sandboxes which used 4 GB of memory. Just for fun, I have checked for the machine name. And I have found some interesting strings there. For example, someone named his sandbox to sandbox A or WenXP maltest. Well, this is not the best idea, but most of them were quite random. This is an actual real screenshot from one of the malware analysis sandboxes. And I want to ask you to shout some of the tips for me why this is a real malware analysis sandbox and not a user desktop. Sorry? No clutter. Yeah. Nothing is installed, yes. Louder, please. Sorry? Yeah, there is no applications running exactly. Yeah, default background, no one uses that. Yeah, it's Windows XP. Yes. Trash bin is empty, so there are so many things on this picture. Again, this is another malware analysis sandbox with debug data, another malware analysis sandbox with debug data. Pretty interesting. But when you look at a real user workstation, this is how it looks like. Actually, I stole this screenshot from the hacked team torrent file, where one of the administrators of hacking team was hacked, and the guy who attacked them stole the screenshots while he was busy working. So if you see this, you can be sure this is a real user desktop. There's no question about this. I have also checked for the number of flash drives used in the sandboxes. Usually it was 0, but there were some cases where only 1 flash drive has been used. So if you want to detect sandboxes via this way, I recommend to set the threshold to 2, because none of the sandboxes have used 2 flash drives, but I have never seen any user desktop with only 2 flash drives used. Again, this is one of my favorites, checking for printers. None of the sandboxes have printers installed, except the default ones, like the Windows, the Adobe, or the Office ones. But all user workstations and desktop has a printer. I've also checked for the number of recently created or modified files in common directories like desktop, documents, folders, app data, temp, and so on. It was not a surprise that almost all sandboxes had a really low value on these. But if you check a real user workstation, you will see a lot of recently modified files in these directories. Now, if you are implementing all these sandbox detection techniques in your malware, there are at least 4 levels where you can do that. The first level is in JavaScript. If you are into exploit kit development, you can still check for some things in JavaScript, for example, the screen resolution. You can also make automated decisions in your malware, hard-coded, which is good because via the dynamic analysis, you won't leak your CNC server data. But again, this is not something super sophisticated, so not everything can be implemented here. Or you can do another way that you leak some data to your CNC server, and the logic on the CNC server decides whether it's your target or not. Or last but not least, you can, for example, leak screenshots to your CNC server and check 3 different screenshots whether it is your target or not. But the best approach is to implement all of these layers and quit or modify your behavior at the first layer when you detect your sandbox. There are also some hard problems for malware analysis sandbox developers. For example, when it comes to they emulate the sleep functions or not. It turned out that in my test cases, most of the sandboxes never even tried to emulate the sleep calls. So if you implement a 4-minute sleep in your malware, you will just skip the behavior analysis. But it is very easy to detect whether sleep is emulated or not. For example, by creating new threads, and one thread sleeps, the other creates some heavy calculations like hashes, and based on which thread finishes sooner, you know whether sleep is simulated or not. And there is no desktop on the world where sleep is simulated, so it's, again, for sure you know that this is a sandbox. There is a solution to solve that called continuous sandboxing, which I don't have time to tell you how it works, but unfortunately it has own problems as well. Another hard problem is the network connection, whether it's simulated, whether there is a real connection, or there is no connection at all. No matter which way you choose in your sandbox, you can be detected. So these are very hard problems. And my lessons learned for this presentation is that if you are a malware writer, there are many, many ways how you can bypass static and dynamic analysis. And if you are a sandbox developer, especially if you are one selling your sandbox to customers for a lot of money, then I think you should really try harder, because nowadays the level is not what I would expect from these sandboxes. And if you are on the blue team or defensive side, you should really test your sandboxes against these anti-sandbox solutions. And what I really recommend to customize your sandboxes so it really matches your desktop environment. So that's all. Thank you for your attention.
So we have time just for one question.
What's
I cannot tell you. The question was, what is the best sandbox out there, but I can't tell you. But if you pay me, I can tell you.
Okay, well, that's the first try. Yeah.
Thank you.
Thank you.